Hi everyone, I am Amorim. In this video, I will present some results of my project entitled Out of Sight, Out of Mind, Confirming the DNM effect in the Rufous Hornero. To keep their territory, owners may face data comparators by intimidating them with visual display, vocalization, or even direct attacks, being this aggressiveness more intense when comparators threaten resources in the core area, in a phenomenon known as certain peripheral effect. In some species, individuals are able to distinguish neighbors from strangers, a phenomenon that reduces the cost they are associated with territorial difference known as the neighbor-stranger discrimination. As a consequence of this social recognition ability, some territorial birds are able to reduce their aggressiveness toward no comparators, channeling the energy to repel strangers instead, what is known as the DNM effect. The DNM effect has been observed in a wide range of species in different taxonomic groups, but like studies for the new tropical Suboscines. Since the phenomenon is based on acoustic trend variations among individuals, it would actually be intriguing to find its occurrence in some Suboscine species. The Rufous Hornero is a Suboscine and new tropical duet species that defend their territory year-round and with a monogamous breeding system with low extra-part paternity rate, also being extremely aggressive toward territorial intruders, like in this example. Previous investigations found vocal signatures in this duet species, suggesting the opportunity to test hypotheses on the behavioral cognition and function of duet song. We evaluated the occurrence of the DLM effect in the Rufous Hornero, focusing on as the bird's response to simulated territorial interaction by neighbors and the stranger. Specifically, we asked whether birds differ in their vigilance and the latency until the first flight toward it over this simulated interaction, considering the distance between neighbors' territory and the locale of emission. The study was conducted in an urban area in Juiz de Fora, in southwestern Brazil, during the breeding season of Rufous Hornero. After color-banding the individuals, we mapped their territory boundaries through 7 hours of observation per couple. We recorded each couple and their neighbor's duet in response to a standard playback. To simulate that duet stranger, we used the record mating of individuals that were living more than 3 kilometers from our student site. We also used the solo song of the Kiskadee, a local commerce species, as a control. We simulated territorial interaction in two contexts, by playing back the duetting a control song at both the territory periphery and at 10 meters from the active nest, hereafter termed as center. We respected a minimum 1 hour interval between trials in the periphery and the center and the 24 hours for a new experimentation. We defined the sequence of playback and the locale of experimentation at random prior to the fieldwork. Immediately after each playback, we recorded during 10 seconds whether or not couples exhibited immediately vigilance, and during 5 minutes the latency until the first flight. The covariance included the distance between neighbors' territory and the locale of experimentation. After some very intense field work, others show higher immediate vigilance odds after a simulated interaction by a duet stranger. In addition, we observed that the response is higher in its territory center, being positively affected too by distance between territory. We also found too that birds took longer to respond to simulated interaction by neighbors in comparison to a stranger, being the response fast in the territory center. Nevertheless, differently from what we found for the immediate vigilance, the latency to fly did not vary according to the distance between territory. Our results suggest the occurrence of the DNM effect in the Rufous Hornero, how it was observed in your Suboscines duet song. But in contrast to previous investigations, our findings support that a duet signal can be used to behavioral modulations according to the emission profiles. We also found an important role of distance between territories for the DNM effect in Rufous Hornero, how previously found in different taxonomic groups. These results suggest that Rufous Hornero may adjust its aggressiveness toward the neighbors using information collected during social interactions. In addition, and how respected to the symptom peripheral effect, our result suggests that Rufous Hornero regulated its aggressiveness according to the threatened offered by the comparators, being the interaction close to nest more threatening than in its periphery. Given the increased density of comparators during the non-breeding season, we believe that the scent peripheral effect and the DNM effect may be modified in Rufous Hornero. In future studies, we evaluated if Rufous Hornero adjusted its aggressiveness during the non-breeding season toward the neighbors, are respected to the nesting neighbor effect. Thanks for your attention and send me questions.